Hi everyone, welcome to the 6th lesson of the CrowPanel-ESP32 Terminal display series. In this lesson, I'll show you how to use Squareline Studio to design and export UI files, and then how to integrate those UI files into your ESP32 project. Since I already explained what Squareline Studio is in the previous lesson, I won't go into detail again. The compiler for this lesson is Arduino, IDE 2.3.3, and ELVGL library 8.3.11. Let's start by downloading the software. Open your browser, search for Squareline Studio, and navigate to its website. Click here to go to the download page, and then select the appropriate version based on your operating system to download it. After downloading, run the installation program. You can customize the installation path, which won't affect its usage. Once installed, click Finish to complete the process. Now you can run Squareline Studio. On the first run, it will prompt you to log in. Click Log In here. If you haven't registered an account yet, click Sign Up to open the registration page and create an account. After registration, simply click Log In to proceed. Next, let's create a UI project. Click on Create and select the Arduino option. You'll notice that under the Arduino section, there's only one option for TFT-ESPI. You might be wondering if Squareline Studio only supports the TFT-ESPI library. No, that's not the case. Selecting the TFT-ESPI library won't have any impact on the UI project you'll design later. It just means that when exporting the UI file, you can choose to generate an additional template code for the TFT-ESPI library. However, in reality, we only need the UI file exported by Squareline Studio, which contains only UI-related code without any TFT-ESPI code. So don't be misled into thinking that Squareline Studio only supports the TFT-ESPI library. So feel free to follow my demonstration. On the right side, you can change the name of this UI project. You can also specify the save path for this UI project. I prefer keeping each UI project in a separate folder for easier access. For the resolution, you need to fill it in based on the board you're using. If you've watched the second lesson, I'm sure you know where to find that information. Open the CrowPanel-ESP32 Terminal series page and scroll to the bottom. Here, you can find the hardware information for boards. Return to the Squareline Studio. Fill in the corresponding resolution here. The angle and offset settings can be left as default. However, it's important to note the color depth. The boards in the CrowPanel-ESP32 series all have a color depth of 16 bits, so make sure to select 16 bits here. Regarding the ELVGL version, as I mentioned in the previous lesson, we installed ELVGL version 8.3.11, so select that version here. Finally, click Create, and you'll see the UI project has been successfully created. Here's the project interface. In the bottom left corner, you have the widget panel, where you can add the necessary widgets. This is the asset panel, showing all available images and fonts. And this is the inspector panel, where you can see the parameters of the selected widget and assign events to it. In the center, you have the visual interface, where you can see what your designed UI looks like. If you want to change the background color of the screen, you can find the style setting in the inspector panel, where you can adjust the background color to any color you prefer. You can even set a background image for the screen. Next, using the widget panel, drag a button widget onto the screen. You can also resize it like this. Add a label widget and modify its text content. If the font size is too small, you can adjust it here. It's as simple as making a slideshow. Creating just one screen would be quite boring. Let's add another screen and place a button on each to switch between them. That would be a great example. In the widget panel, click on Screen to add a new screen. The newly added screen will appear to the right of the original screen, and you can see it in the view. Again, add a button to it, but I'd like to use a different color for the button on screen too. Furthermore, I'd like to add an appealing widget. Let's use this one. Lastly, add a label and adjust the font size. 40 seems to be a better fit, so let's use that. To save space, let's also use 40 for Screen 1's label. Alright, the design for both screens is complete. I'll simulate it to see how it looks. It looks good, but the button doesn't have the function to switch screens yet. To achieve this, you need to add an event to the button. Select the button, and at the bottom of the inspector panel, you'll see the ADD event button. Click it to add an event to the button. Okay, after adding the event, you need to configure the trigger method. Here, I've chosen release, which means the event will be triggered only when the button is pressed and released. You can try other options to see the difference. Next, configure the event action. Since I want to switch screens, I'll select Change Screen. Click a DD to see more detailed configurations. Select Switch to Screen 2, and that's it. You can also experiment with modifying other parameters to see what effects they have. As LVGL retains and consumes memory for the previous screen when switching, I'd recommend deleting Screen 1 when switching to Screen 2. Get into this habit, or your program might crash due to memory overflow when designing more complex UIs. Similarly, let's add a similar event to the button on Screen 2. When the button on Screen 2 is released, it should switch to Screen 1 and delete Screen 2. Alright, that's it. I'll test it by clicking on the Simulate button. Yes, that's the desired effect. Now, with the interface designed, I need to export it as a UI file so that the Arduino IDE can use it. Click on File in the top left corner, open Project Settings, and find File Export. First, set the root directory for this UI project. This was already determined when the project was created, so I'll keep it unchanged. Next, specify the export path for the UI file. I'd recommend creating a folder within this project to store the UI file. Here, you need to specify the path to the LVGL header file. Just enter LVGL8. Finally, check this option, Flat Export. This will export all UI files into a single folder without any subfolders, which is more suitable for the Arduino IDE structure. After configuring these settings, click Apply Changes. Then you can export the UI files. Click Export and you'll see two options. Please select the first one to export only the UI files. The export process is very fast. Once completed, you can find the UI files in the path you set earlier. Paste. Here are the exported UI files. Next, I'll demonstrate how to add these UI files to an Arduino project. Since steps are the same for both boards, which I will demonstrate in ESP32 RGB screen. If you have ESP32 SPI screen in your hand, you can still complete this lesson by following the steps below. Open the course files. If you're unsure where to download the course files, please check the video description below, which contains a link to the course documentation. In the course files, locate the code for the 6th lesson and open the folder for the ESP32 RGB screen version. Copy all the exported UI files into this folder. This way, when you open the example code for this lesson, the UI files will also be opened, making it convenient to browse the UI-related code. In the example code, according to the comments, we won't be using LVGL's demo for this lesson, but instead our own designed UI. Therefore, there's no need to include these two header files. Moving on to the display and touch driver, the content was already covered in the second lesson, so I won't go into detail here. Mouse down, locate the LVGL demo function. Since we won't be using LVGL's demo for this lesson, you can comment it out or delete it and replace it with the UI loading function. But which function is used to load the UI? Open the UI.c file and find the function named UI_init. This function is responsible for loading the UI interface. It initializes screens 1 and 2, and finally loads screen 1. Therefore, you need to add this function to the setup function so that the UI interface will be displayed when the program runs. Remember, when you use functions provided by you, don't forget to include its header file, or you'll encounter errors during compilation. Another thing that's easy to miss is that I used a 40-point font in Squareline Studio, so I need to enable this font in LVGL. Open the library directory and find the LVGL configuration file. Open it, search for font, and in the font usage section, each macro represents a font of a different size. Since I'm using a 40-point font, find the one for 40 and enable it. Of course, you can enable all font sizes, but it will waste a lot of space. Therefore, I recommend enabling only the commonly used ones. Click Save and close it. Now, I've integrated the UI into my project. Let's compile and upload it to the board to see the result. Click Tool to configure the compilation settings. If you're not sure how to do that, please refer to the content in the first lesson, as the compilation process can take a long time, and incorrect configuration will waste a lot of your time. Once configured, click Upload. Since the upload process can be lengthy, I'll speed up this part of the video. After the upload is complete, you will see the interface I just designed in Squareline Studio displayed on the board, and the button events will trigger normally. Alright, that's the process of adding UI files to ESP32 RGB display board. If you're using the ESP32 SPI display board, you can still follow the steps of ESP32 RGB screen to make the UI effect you want. Click Tool to configure the compilation settings. If you're not sure how to do that, please refer to the content in the first lesson. Once the upload is complete, you will see the interface I designed in Squareline Studio displayed on the board, and the button events will trigger normally. That's it for this lesson. If you find this course helpful, please don't forget to subscribe to my channel. Thank you for watching, and I'll see you next time.